To find the volume of a solid of revolution using the shell method, we integrate the circumference of the shell times its height. We use y values for a horizontal axis and x values for a vertical axis. Let's find the volume of the solid formed by revolving the region bounded by y equals x minus x cubed, and the axes about the y-axis. Using the shell method, we draw a representative vertical slice. The height of the shell, h of x, is the function itself. The radius, r of x, is simply the distance from the y-axis to our slice, which is x. Picture that thin slice as a hollow cylindrical shell. If we spin just this one sliver all the way around the y-axis, it sweeps out a thin tube, with circumference 2 pi r of x, and height h of x, adding up infinitely many of these thin shells. From the y-axis out to x equals 1, sweeps out the entire solid. We set up our volume integral as 2 pi times the integral from 0 to 1 of x times x minus x cubed. Evaluating this integral yields a final volume of 0.26 repeating pi. Now let's find the volume of a region revolved around a shifted axis, the line x equals 2. We draw our vertical slice. The radius is now the distance from the slice to the axis of rotation, which is 2 minus x. The height of the shell is the top function minus the bottom boundary of y equals 1. Spin just this one slice all the way around the line x equals 2. And it traces out a hollow cylindrical shell sitting away from the axis. Since the region never actually touches x equals 2, stacking infinitely many of these shells, from x equals 0 out to x equals 1, sweeps out the full solid, a hollow bowl shape with a cylindrical hole running through the middle, because the region never reaches the axis of rotation. We substitute these into our shell method formula, integrating from 0 to 1. Evaluating this integral gives us a total volume of 1.93 repeating pi.